Welcome to Zeiss Inspect X-Ray. In this video, I'll show you different options to process your volume data in Zeiss Inspect X-Ray. The software offers countless tools to inspect volume data. Some require only volume data, others require a polygonized mesh. Depending on your part, you may also need to separate different materials, or maybe you're only interested in certain areas of your part. To best support your inspection tasks, I want to show you some options to process your volume data for inspection. We'll talk about how to identify different materials, how to create regions of interest to define your polygonization and/or inspection areas, and how to polygonize the volume data to obtain a mesh. If you want to try Zeiss Inspect X-Ray, take a look at the description below. There, you'll find links to download the software, request a free trial, and download training data. My project contains the measured volume, as well as a part, which contains the linked volume and a cat. The cat is used for the alignment in the project, which is a pre-alignment volume. It's a great, easy-to-use alignment if you have cat data for your part. To learn more about it, look at the tech guide. The part itself consists of two different materials, which makes it perfect for the first function I want to show you: identify materials. Use identify materials when you have a part with multiple materials and you want to separate them. By separating them, you can also polygonize and inspect them separately later. Select the volume in the Explorer or the 3D view. Then open Identify Materials in the main toolbar. As you can see, it's the second function in the main toolbar, which indicates that you'd usually use it at the beginning of your workflow. Let's take a closer look at this dialog. At the top, you see the selected volume. By the way, it doesn't matter if you select the original volume or the linked volume before calling the function. The software always works with the measured volume here. But contrary to the functions under Edit Volume, Identify Materials does not replace the original volume. Instead, it creates a new volume element, but more about that later. You can choose to update all, none, or the currently selected linked volume. Okay, now let's talk about the histogram and the preview. The histogram and the table underneath show how many different materials were identified by the software. In this case, that's the background in black, so air, material 1 in red, which is a plastic material, and material 2 in green, which is metal. You see the same colors in the preview. Use the different axes on the bottom of the preview to change the view and the spin box to change the position of the preview plane. You can also hover over the spin box and use the mouse wheel to do that. And beside that, you have different preview modes. Materials Fast allows for a faster preview computation, but might not be completely accurate, especially along boundaries between different materials. If you want to preview the actual result, use Materials Computed. Just be aware that the computation time is a bit longer. With Material Boundary Areas, you can visualize the boundary areas the software identified. I'll switch back to Materials Fast for now. In addition to the preview in 2D, you can also show a preview in 3D. To do that, activate the option down here, and then use Ctrl and the left mouse button to define the preview position. You can increase the preview area here. Back to the histogram. You can change the gray value allocation for the different materials by moving the material indicators in the histogram. To reset the gray values to the original computation result, click here. You can also add materials manually if the software failed to identify them, and delete falsely identified materials. If you're only interested in one of the materials in your part, don't delete the other ones. Instead, untick the box under Create. This means the material will be excluded from the new volume element. If you delete the material or materials, the software assigns all its voxels to the remaining material, in this case material 1. When you look closer at the preview, you'll notice that the material identification around the metal insert here isn't quite right. The first thing I'll do is to set the preview to materials computed. This gives me a better indication of the final result. Since the inconsistencies remain, we have two options. Option 1 is to change the identification method to connected areas. As you can see in the preview, this method works great in this case. Connected areas assigns boundary areas to the most plausible surrounding material. That means it's better at dealing with artifacts, blurry boundaries, and beam hardening, for example. Option 2 would be to adjust the material boundary factor. This may be necessary if neither identification method provides satisfactory results. For more information about the identification methods and the material boundary factor, please consult the tech guide. In our case, we achieved the desired outcome, so I'll click OK to execute the function. The software creates a new volume element with the suffix mat. It replaced the linked volume in the original part, and it created two new parts, one for material 1 and one for material 2. I'll rename them Plastic Material 1 and Metal Material 2. Let's take a closer look at one of the new parts. The software added a linked volume to the part, the one we created by using Identify Materials. And the software created a volume region based on the material identification. That's what you see displayed in the multi-view. The voxels are now colored according to the material they were assigned to. Now, you might wonder why you would need a volume region for the material. Thanks to the volume region, you can adapt the automatic material identification. If the computed material identification is flawed, for example, you can edit the associated volume region and correct that. To do that, you can use the last 4 functions under volume regions in the main toolbar. Since this is a more complex topic, which requires more background knowledge, I won't be able to cover it in more detail here. But if you want to read up on the different functions, consult the tech guide. To learn how to use them, check out the Inspect X-ray Basic e-learning. What I do want to show you is how to create a volume region for a region of interest. To do that, we'll use the complete part. Display the linked volume in the multi-view. I'm interested in this cylinder, so I want to create a volume region based on the cylinder. To do that, I need to construct the cylinder first. Open Construct, Cylinder, 2-point cylinder. Use Set Focus Point to display the cylinder in the section views. To create the cylinder, you need to define 2 points for the cylinder axis. You can use the section planes in the section view to help you. Use Ctrl and the left mouse button and click 2 points in one of the section views to define the axis of the cylinder. You can change the position of the points with drag and drop. It's best to have a bit of excess cylinder height so that the top of the cylinder can be closed when we polygonize later. To set the size, I'll use Radius by Point and click another point with Ctrl and the left mouse button. Check the other section views to make sure the cylinder encloses the region of interest. Then click Create and Close. Before we continue, we need to adjust the properties of the cylinder. You must enable the option Alignment Required. Here's why. A project can contain different alignments. You can switch between them at any time, and the software recomputes elements and inspections in the newly selected alignment. That would mean that the cylinder's position may shift if you switch to a different alignment. Since we want the volume region to be based on our current selection in this alignment, we need the option Alignment Required. When it's active, the cylinder and the associated volume region will always be computed in the pre-alignment, or whichever alignment you select here, no matter which alignment is active in the project. Now that we have the cylinder, we can create the volume region. In the main toolbar, open Volume Regions, Volume Region from Geometry. Select the cylinder with Ctrl and the left mouse button. Down here, you can see which part the volume region will be assigned to. This is handy when you're working in a project with multiple parts. Then click Create and Close to create the volume region. You'll find it in the Explorer under Actual Elements, Volume Regions. Before we continue with the polygonization, I want to point out that you of course have many more options to create volume regions, as you can see under Volume Regions. I chose a straightforward one to show you, but feel free to give the other ones a try. You'll find more information about each one in the tech guide. Alright, let's move on to the polygonization. When you polygonize a volume, you create a surface mesh, which you can then use for further inspections and comparisons to CAD. I want to show you how to polygonize the volume region we constructed based on the cylinder and the two materials we separated with Identify Materials. Let's start with our region of interest around the cylinder. In the main toolbar, open Polygonize Volume and select Polygonize Volume. The overall layout of the dialog should look familiar. We have a histogram, the 2D preview with navigation commands on the right, and the possibility to display a preview in 3D if you activate this option. Now let's look at the parameters. Under Materials, select the part you want to polygonize. In my case, that's pre-filled correctly. Under Material, select by threshold. That means the software uses the gray value threshold to distinguish between the material and the background. If you used Identify Materials previously, you can select the different materials here. But I want to show you how to use regions of interest to restrict the polygonization areas without using Identify Materials. To limit the polygonization to the region of interest, activate Limit to Region and select the volume region cylinder. When I switch the viewing plane to X, you can see the volume region highlighted in yellow. Select the polygonization quality. I'll use Standard. To polygonize the volume, click OK. Limiting the polygonization to areas of interest speeds up the computation. So if you don't need the entire mesh, use volume regions to polygonize the areas of your part that are relevant for your inspections. Once the computation is done, you'll find the mesh in the Explorer. Okay, now let's talk about polygonizing the two materials we identified at the start of this video. Remember, Identify Materials created two new parts, each containing a volume region for the respective material. Now to polygonize them, you could use Polygonize Volume, but there's a faster and easier way. Polygonize Multi-Material Volume. Under Materials, you can choose which parts and volume regions you want to polygonize. You can also add another part using the plus here, or delete one. You can select the polygonization quality. I'll use Standard again. For more information about the different quality settings, check the tech guide. To start the polygonization, click OK. Once the computation is done, you'll have two meshes, one for each part. You can now proceed to inspect them together or separately. If you want, you can also change the mesh color in the properties. By default, meshes are displayed in green in the section views. You can change this color in the properties too. So much for the different options to process volume data in SeisInspect X-Ray. Now, depending on your application, you may need some of these steps, or all of them, or maybe none of them. In this video, I simply wanted to show you some of the possibilities. Let's quickly summarize. With Identify Materials, you can process multi-material parts and separate the different materials. Each material is assigned to a new part, and the software creates a volume region for each material. This allows you to adapt the material selection later if necessary. By using Identify Materials, you also benefit from the polygonization command Polygonize Multi-Material Volume, which allows you to create a mesh for multiple parts and volume regions. In addition to creating volume regions based on materials, you can create volume regions for regions of interest. The software offers various functions to do that. The one we looked at was volume region from geometry. And finally, you can use volume regions you created to restrict the polygonization to regions of interest. That's it for this video. If you want to know how to use meshes and CAD data for inspections, check out the next video in this playlist. And if you're looking for more comprehensive training, check out the Inspect X-Ray Basic e-learning. You'll find the link in the description below.